Hi and welcome back to the second part of the CoEDL Summer School visualization course, where we're looking at how we visualize language data for analysis and communication. In this second video tutorial, we're going to use the knowledge that we've learnt about observable and Vega and build a second visualization. This visualization is going to build on the knowledge we learned in the first tutorial and add some new knowledge, like how we add interaction into a visualization that lets the user select which data set to display. We're also going to use different types of marks and introduce you to how you do some simple transformations of data in Vega. As always, if you want to follow along with this video tutorial, you can go to the links in the description of the video, and that will take you to the observable workbook for the course. This workbook has a blank Vega specification ready for you to add in all of the details that we need to create the plot. It has a cell where our visualization is going to appear and some information about the data set that we'll be using, particularly the source of the data. And then down the bottom, we have the data set itself. So the visualization that we're creating today is inspired by a data set I found at a site called elinguistics.net, which if we go to the site, it's this table that's comparing a set of words in English and German and looking at how similar they are based on a comparison of the consonants in each word. So you can see in this table that authors have identified when there's a related consonant match and when there's an exact consonant match, and I've assigned a set of points to the data. But just looking at this table display, it's not clear how much each consonant match is contributing to that overall score. The authors do give us that information. If we go across to other places in the site, they tell us why they've chosen those words and tell us about the clustering that they use to decide what score to give each pair of consonant sounds. So I thought it would be nice to be able to see all that data in a single visualization. So I've taken the data from this table and just using Excel, I rearranged it, exported it as a comma-separated values file, and then I've uploaded it and done some simple transformations. So it's all more or less ready for us to visualize using Vega. And you can see down the very bottom of our observable workbook, there's a cell that says import at Lydia Seaburn /CoEDL-summerschool-data. And if we open up that cell, it's telling us that we're importing another cell from another workbook, and we're giving it the name data. So, and then if we go up the cell just above that, I've just typed in the word data, and that's displaying that rearranged table for us. So each element of the array is an object. It's got a property called English that tells us the English word, property called German that tells us the German word, property called econs, and if I just click to open up that object, it's showing us That's an array of the English consonants. G-cons is the German consonants. Pairs is the score for each consonant pair based on the table from the site. So if we go to a word like ear and or in German, then we have an exact match between the single consonant in that word. So to start the visualization, we need to go up to our Vega specification and we need to start filling in those properties. So we'll give the chart some height. I'll just make it a square to start with. And if we go down to our data, see we've got an array there. We need to add a JSON object, so add curly brackets, add the property name, and we're going to call this dataset words, add the property values, and we're going to go down. Remember, we imported our data as the variable data, so that is what we'll type for our values, and we've seen that that goes dark blue, which means it's recognized that that's a variable. And if we press Shift-Enter, we've seen that because we changed the height, our Vega chart cell has gotten bigger. And if we look up here, if we just click this small triangle at the top of our spec cell, we can see those same properties, and under data we have the name words and our array of objects is all in there nicely. When we look at any one of these objects, we have most of the properties of our data are just a simple number or text, which we call string values, but a few of them are actually array values. And this is a slight problem when we're trying to visualize with Vega, because Vega likes things to be in a form that they call a long table. So every unique bit of information is contained in its own row of the table. So what we're going to do is we're going to apply a simple Vega transformation that takes each one of these data values and creates a new row with the English, German, number, and average properties the same, and just the econs, gcons, and pairs values will vary. So what we'll do is, still within our data object, we're going to add a new property, and it's called transform. And the transform property takes an array, because that lets us gives us the freedom to apply multiple transformations to the single data set. And then each of those transforms is itself an object. I'll just move some of these brackets to new lines. So the first transformation that we're going to apply is we have to give it the property type, and it's going to be called flatten. And that's that unpacking transformation that I was just describing. So comma after flatten, and then we have to tell it which properties to flatten. We do that using the property fields, the next. And the properties are econs, gcons, and pairs. Oh. We're also going to add a second transformation. If we go over to the visualization that we're trying to build, you can see it's only showing us one word at a time. So to do that, what we're going to do is we're going to apply a filter transformation. And to start with, we're just going to filter everything out so that we show, let's see, let's say the word death. So we've added a comma at the end of that object, adding a new object, again telling it a type, and it's going to be filter. And filter takes the property expression, EXPR, short for expression, and we're going to say if datum dot English double equals, and using single quotation marks so it doesn't get confused with the double quotation marks we're using around the word death. So what that's going to do is it's going to look through each of our data objects and only keep the ones where the English property is equal to the string death. ShiftEnter. Just going to close that. Now, you might think that you'll never be able to keep track of all of these transformations and what properties they need to have. Truth is, I can't either. So what I do is go to the Vega docs, and if we go to the table entry that says transforms, click on that. This tells us a big list of the transforms that we can apply. Select any of them and it will tell you the properties that you can have, which ones are required, and give you an example of what that transformation will look like, and usually what it will do to a data set. So that's a really useful resource that you'll end up using pretty much every time that you want to apply a data transformation. So once we've got our data set all sorted and we think it's in the right form, to make something appear on the page, the next thing that we have to do is we have to create some scales which are going to transform from our data into visual marks. So when we look at our data, you can see our values are either letters or we have numbers. So numbers, we saw in the first tutorial that we can use a linear scale and map that to the physical space on our screens. We did that by creating an object. The scale needs a name, so we're going to make this we call it Y scale because it's going to be going on our vertical Y axis. It needs a type, which is going to be linear. Remember, it needs a domain, which is the values, the data values and it needs a range. So for the domain, we're going to say our data set is the data set words. Our field is the set pairs. And then it needs a range. The range is telling us the visual values that we're transforming into. So here we're going to use that keyword height. So that's created a scale that transforms from our pairs data object, which is a number from 0 to 100, into the visual values from the bottom of our chart to the top of the chart. Our other two key data values that we want to visualize are both actual consonants that make up the words and correspond to those numerical values. So one way that we can display alphabetic values in a visualization is by looking at their order. In this case, we're going to look at their order within the word. So Vega, as well as supporting linear scales, also supports a number of visualization scales which work with ordered data. And so one that we'll be using is called a band scale, which just maps the, in our case, horizontal space, separates it out into a series of what they call bands. So what we'll do is, again, put a comma after our Y scale object, create a new object, give it a name. In this case, we're going to call it GX scale because it's for the German consonants. And we're going to give it a type, and that's where we tell it that this one is going to be a band scale. It still needs a domain. In this case, we can just copy this object across, come from our dataset words, and this time we're going to look at the fields German consonants, G-cons. And it's going to have a range. Don't forget the comma at the end of each property. Range is going to be the chart width. And then we close our curly bracket to finish creating that horizontal scale. So the only difference here, apart from the field of the data field that we're referring to, is this type property. We're also going to create a second band scale, and that's going to let us arrange our English consonants. So give it a name, scale, and just going to copy all of this. Type domain is going to be the English consonants, and our range is still going to be open. Now we still can't see anything in our plot. That's because everything that we've created so far is really working on the back end of the visualization. To create something on the page, we need some visual marks. So the In this case, we're going to use the rectangle mark. So it takes the type property, we set that to be rectangle, just rect, short for rectangle. We give it the property from and tell it that it's from the dataset words and then we tell it to encode takes this time on enter when the mark is created. We're not going to do anything with the mark. Instead, on the update property, this is where we tell it the rules for how to set the properties of the marks to correspond to the data and the scales that we've just defined. So a rectangle takes the property x, takes the property y, takes a property y2, which sets the other end of the rectangle. So bottom and the top, and takes a property width. And then we can do some formatting properties. So we're going to give it a property fill as well. That's going to give it a background color. So our X property is going to start with, we can use either of our GX scale or our EX scale. Just going to use our German one. So we give it the property scale to let it know that it's going to be applying a scale, GX scale, to the data field. The important thing is we get the same data field that we used in this scale, so G columns. Our Y value is going to be set using the scale, Y scale, and the field pairs. Our Y2 scale, so we've set one end of the rectangle to be the vertical value up and down of our 0 to 100 quantity. The other end of the rectangle we actually want to pin to the bottom of the chart. To do that, we need to use that property scale and tell it to use the Y scale, but then we just tell it to use the value 0. So instead of giving it a data field, we say wherever the value 0 maps to in the Y scale, which is the bottom of the chart, that should be the other end of your rectangle. For the width, we also use a scale. We still use our GX scale, and we give it the value, give it the property band, and just say to be equal to 1 band wide. And then we give it a fill value. This is just setting the color, so we just give it a straight boring value, so every rectangle gets the same value. And I'm going to use my good old favorite cornflower. Shift-Enter. Suddenly, we have a chart. Now, if we see here, we've got some overlap happening. We're going to add some padding to our scale here. This is our horizontal scale. Padding, let's say 0.05. We're going to do the same to our other X scale. And here we have a much neater value. Now, we still don't know what this corresponds to. To do that, we need to add axes. Our axes have the property orient. Let's make a scale over at the side. So property left. A scale. Our Y scale. And let's add a property as scale at the bottom, so orient bottom scale is we've been using our German consonants. Oh, this needs to be an object. And our scale name is GX Film. And suddenly we have our German consonants. And we have our value going up to 70. So this is showing us something, but it's not quite showing us what we wanted. It's what Vega is doing is it's calculating that of the data values that we had, ranging from 0 to 100, our data that once we've done the filtering for the words for death, then it's chopped off so that those values only go up to 70 something, nearly 80. So that's where it's cut off its Y scale. To fix that, we can use the domain for our Y scale and change it to the value 0 to 100. If we press Shift Enter, we go down, we can now see that our scale now runs from 0 to 100. So that's a bit better. And if we want to change the word, so let's look at the word water instead. Shift Enter, we can see that the values have changed and the consonants we have down the bottom have changed as well. But we'd actually like to be able to see the English as well. So let's move our German scale to the top. Let's add a second axis at the bottom and use our English, our EX scale at the bottom. And here we have W versus V has a score in the mid-80s. S compared to T has a score in the mid-50s, and R and R match. We change to another word like ear. And just changing up in our data transformation, applying a different filter, filtering for a different English word, and that gets us a new finds a new data set each time. So this is quite nice, but we can't rely on a reader being able to go up and know which words we have to display and type them into our data. What we'd really like is some nice interactive feature that lets the user select the word. So to do that, Vega has a property called signals. So it doesn't matter where we put the signals property after that initial schema. I'm going to put it just after the title. I'm going to put in a property signal. Signals, like most of these other properties, is an array, and then we need a comma after the array so that Vega knows we've now moved on to the data property. Each signal, you may guess, is a JavaScript object, and signals take a name. In this case, I'm going to call it word singular because it will be the word that we've chosen to display. I'm going to give it a property called value. This is its initial starting value. So let's pick the word water. And then I'm going to give it a property called bind, which lets us attach a standard HTML input to it. So we can apply radio boxes, which let the user check things on and off, or you can attach what I'm going to do, which is a HTML selection box. So the bind takes a property input, which says where we specify what kind of input it is. So here I type the word select, and then we have to provide some options for the user to select from. So there's ways that you could do this with code. I've made it really easy, and down the bottom of the observable notebook I have a variable called list, and if we just copy that list, so open up the observable cell, copy that list including the square bracket, jump in back into our spec and paste that list. That's going to be all of our options. Press ShiftEnter. Now if we scroll down to our visualization, we have a handy selection that has all of our options, but it doesn't actually do anything when we choose a different word to do that, and it's giving us quite an ugly title for our selection box. So to fix that part, within our binding object we can provide a name for the input. So here we're going to give a description for anyone who comes across our visualization as to what they should do with that selection box. So choose a word pair for and put a couple of spaces at the end so that there's a bit of room before our selection box starts. Now if we press Shift-Enter, we've got an error because I forgot to add a comma at the end. Press Shift-Enter again, and we see we've got a much nicer title. But the more problematic bit is that our selection box still doesn't do anything. So the reason that Vega has these things called signals is because they take the input and they generate a signal, hence the name, that the rest of the Vega specification can hear. So we can use this name of the signal here, word, anywhere else in the plot. In particular, we can use it in our data object within this filter transformation that we've got. So instead of saying check each of our data entries for whether they match the word ear, say check whether they match a variable signal word. Now if we press Shift Enter and we choose a new word, we have switched around and added some interaction. We're going to add a titles to the axes. So go to our axes and add a title. Ta-da! So the clever trick that we used in this case is that we only needed one of our scales, one of our horizontal scales, to actually create the plot. We just used to encode our marks variable, we just used the GX scale. But by defining both a scale for the English consonants and for the German consonants, what we're able to do is piggyback on Vega's infrastructure and let it create these scales for us that are displaying each of the sets of consonants. And that's all for this session. I encourage you to play around with the visualization, try different scales, different attributes of the mark, go back to those Vega docs and have a look at the different kinds of data transformations that are available. If you know of different ways of comparing consonant values and obtaining a numerical value about the difference between consonants, I encourage you to create a new data set and use this visualization to have a look at that data. I'll be back soon to show you some visualizations that we can use when we're not just comparing English and German, two languages, but we're comparing a whole raft of languages at once. Bye for now. Remember that you can subscribe to this YouTube tutorial to stay up to date on all of the videos as they're created. Bye!